So talking about physical and chemical changes, some very basic fundamental ideas here. So what you need to know is a physical change. Physical changes often accompany chemical changes. How do you know if something is only physical versus the physical showing that there's also a chemical? So if it's just a physical change, if it's physical only, then what that means is there's no change in what the substance is. There's no change to the identity. What that means is no bonds are broken, no bonds are made. Nothing changes in terms of what it is, just how it appears. So things that are alterations in shape or appearance only. So if I have a piece of paper and I tear it up and it's still paper, so the chemical composition of all the carbon and hydrogen and oxygens in there and how they're bound together to make it be fibrous paper are still there. Okay? It's just at a different shape. So any sort of grinding or stretching or any physical alteration, hey, if I dump more in or I take some out, so it's mass, it's quantity, none of that changes. The other thing is that we can change the phase things are in, but again, they're still the same. So for example, water. If I put water in the freezer, it becomes ice. If I let it sit out, room temperature, it becomes water, liquid water. If I put it in my teapot and turn the heat on, it becomes a vapor. Even in this picture here, you've got all three phases. You've got snow on the ground, that's frozen water. You've got liquid water there in the middle of the scene. And then you've got the clouds, and the clouds have in them water vapor, waiting to perhaps freeze and come back down. But they're all water, even though they look different. And even though I've added some heat or taken some heat out of the mixture, all I've done is rearrange how the molecules stick to each other. I haven't broken any bonds. I haven't made any new bonds. What's holding them together when it's a solid are weak attractions, but not specific bonds between atoms. Okay? In comparison, a chemical change is one where new substances result. So maybe if I'm decomposing something, I'm just breaking bonds. In most cases, I'm breaking bonds and making new bonds. I'm rearranging the way the atoms are attached to each other. Now, how do I know reactions happen? Some of the signs. Definitive signs, the top three are definitive. If I combine two things and all of a sudden I get bubbling and fizzing, or a funky smell that wasn't there before, then I've made a gas, right? And gas production, again, different than like boiling water. I've turned the water from a liquid to gas. But here I'm combining things and there's an interaction that results in the production of a gas. Well, then a chemical change has happened. Also, if I have two solutions where things are dissolved in them and I mix them together, and now all of a sudden I get a solid, a precipitate that comes out of it, well, again, I've rearranged things because now I've taken two things that dissolved in water, and when I've combined them, some new arrangement has happened where things stick together and like each other more than the water, and they become solid. The third one that's not so obvious, and you need to test it using a conductivity tester or a device that has two electrodes and it's connected to a light bulb. So does the circuit get complete when you put the solution when you immerse the electrodes in the solution, is a change in conductivity. If something isn't very conductive, and then I combine it with something else that's also not conductive, and now I get something that's more conductive, or vice versa, things that are too conductive, and then when I combine them, there's a rearrangement so that I get something that isn't as charged in the solution and doesn't carry electricity. Well, then that's the sign that tells me that bonds have been made and broken. Something's been rearranged. The other two often accompany chemical changes, but there are some exceptions. So if heat is given off or taken in, so something feels hot or cold as a result of me combining substances, often that's a sign that a chemical change is happening because there's an energy change. But it can be true that when you dissolve things or dilute things, and I'm not changing their identity, just changing how they are in their mixture, if you will. Like if I had sodium hydroxide to water, as the sodium hydroxide dissolves, which I guess on some level the attractions between the sodiums and the OH groups are being pulled apart and surrounded by water molecules. it gives off heat. And you say, well, it sounds like I've broken some bonds. Yeah, but if I evaporate all the water, guess what? I get the sodium hydroxide back. It's still there. I haven't changed it into something different. Same thing with color change. A lot of times, if you have a combination or a reaction that results in it having a different color, most of the time that's a good sign that chemical changes happen. Some of them are reversible, which means that maybe it's not a really hardcore change. It's just you have some molecule that has certain optical properties, absorbs certain colors of light and reflects others, so it looks a particular color. And then if I throw a bunch of hydrogen ions at it, in other words, if I change the pH, the hydrogen ions may kind of stick to some of the ends and change the optical properties, but it's very reversible because they're not really sharing electrons. They're not making new bonds. So it is reversible if I do something to add OHs and take the H's away from that molecule and turn the H's and the OHs back into water. Maybe the color changes back, okay? And that's kind of how indicators work when we talk about pH and acids and bases.